All right, so our first test of the year will deal with sequences of different types here in Chapter 1 and some solving of equations and inequalities. So on the test, you'll have some questions dealing with determining the type of sequence it is, having to find terms in a sequence, writing the recursive rules for a sequence, finding the long-run value if there are any, some questions involving sequences, and then you have to also solve some equations and inequalities. And on all tests, there will be some questions from previous material. Since this is a first test of the year, the questions from previous material will cover things that you learned possibly last year in geometry or the year before in algebra. So let's look at some examples of things that you might see on the test. Starting with these. What type of sequence and the recursive rule for this? Here we have 2, then 7, then 12, then 17. So to go from here to there, and there to there, and there to there, if you add 5, that will get you from one term to the next. So therefore, this is an arithmetic sequence. And the constant difference is 5. And so then if we're going to write this recursive rule for it, as always, the first thing you should say is u sub 1 is equal to 2. If you can do that, at least, you're going to get yourself some points because that's part of the sequence. And then every other term is found by taking the term before it and adding 5. And so u sub 1 equals 2 and u sub n equals u sub n minus 1 plus 5. And there is the recursive rule for that sequence. Now, if we look at this one here, it goes from 4 to 1 to 1/4 to 1/16. Now to go from there to there and there to there and there to there, if you try to add or subtract, like here you're subtracting 3, but if you subtract 3 from 1, you don't get 1/4. So therefore it's not adding or subtracting. And to go from here to there, you could say, hey, I'm going to divide by 4. And then if you take 1 and divide it by 4, that works as well. And then if you take 1/4 and divide it by 4, that works as well. So this one, because you're dividing by 4 each time, that makes it a geometric. And the other way to look at this is dividing by 4 is the same as multiplying by 1/4 or 0.25. Either way, it's the same thing. So therefore, when you write your recursive rule for this particular sequence, you would say u sub 1 is equal to 4. And u sub n is equal to u sub n minus 1 times 1/4. Or you could say u sub n equals u sub n minus 1 divided by 4. Same thing, just different way to write it. And of course, if you want to do the decimal thing and put 0.25 here, you could do that as well. All right, moving on to the next one here, type of sequence, and we have to list the first 5 terms. So this says u sub 0 is 8, u sub n equals 1.2 times u sub n minus 1 plus 6. So because we have this multiplying and this adding, it's two things, so it's not a geometric, it's not an arithmetic. It would be considered a shifted geometric sequence. And then to figure out the terms, since we're writing the first 5 terms, the first term is 8. Even though it says it is u sub 0, 8 is still the first term. Then to figure out the next term, you take 8 times 1.2 and add 6 to it to get 15.6. And then you have to take 15.6 times 1.2 and add 6, and you will get 24.72. And then when you keep hitting your equal sign on your calculator, the next number is 35.664. And the final one is going to be 48.79. Now, if you go even further and write 64.56, because that is since this is u sub 0, this is u1, u2, u3, u4, and u5. If you do that, you're still okay as long as you have this term written here. If you forget to write this term, if this term isn't here, and you write this, well, you've written 5 terms, but they're not the first 5 terms. You've actually got terms, the second term through the 6th term written. So make sure you include this one. If you include this one and you include the 64, you won't get anything wrong because that is the next term. You just did one more than you needed to. All right, looking at this next one, writing the first 5 terms here, we are just multiplying by a -2. So therefore we are at a geometric sequence. First term is 15, then it's going to be a -30, then a +60, a -120, and a +240. And there we have the first 5 terms. Next one, type of sequence and the first 5 terms. Hey, it's starting at 18. U sub n equals u sub n minus 1 minus 7. So this one is an arithmetic sequence with the first term being 18. And if you take 18 minus 7, you get 11. And then 11 minus 7 is 4, and 4 minus 7 is a -3, and a -3 minus 7 is a -10. And there you have the first 5 terms. Type of sequence, first 5 terms, and try to find the long run value. All right, since this is 0.8 times u sub n minus 1 plus 15, we have a shifted geometric sequence. And let's see. You're going to start out as the first term is 80,000. And then if you take that times 0.8 plus 1.5 or plus 15, you will get 64,015. And then if you take that okay, then the value after that one, let's see here. You take 64015, and if you're using your calculator, you should be able to just push the equal sign from here on out. The next number is 51,227. The next value after that is 40,996.6. The next number after that is 32,812.28. And it continues on forever and ever. And if you keep pushing the equal sign, you will eventually get to a value of 75. So that would be the long run value. Now, if you don't want to go through that whole process of pushing the equal sign to get to the long run value, if it is something that is going to be going to a long run value, you can remember substitute a variable for u sub n and u sub n minus 1 to get x equals 0.8x plus 15. And then solve for x. Subtract 0.8x. And then you'll have 0.2x equals 15. And if you take and divide by 0.2, 15 divided by 0.2 is 75. And then you can save yourself some time and not have to push the equal sign all the time. Or you can just keep pushing the equal sign and get there as well. All right, next problem. Type of sequence, the first 5 terms, and the long run value. So here we have 50 times, and then u sub n equals 1.15 times u sub n minus 1 minus 10. So our first term is 50. And then if you take that times 1.15 and subtract 10, you will get 47.5. And then if you take that times 1.15 and subtract 10, you will get 44.6. And if you take that, do the same thing, 41.3. And then the next number is 37.5. Well, if you keep doing this one, it's going to continue to go down, so the long run value is non-existent. There isn't one, because it continues to go down forever. So, no long run value. Now, if you were to take this and try to solve this x and an x, you are going to get x equals 1.15x minus 10. And then if you subtract 1.15x and minus 1.15x, you will get a negative 0.15x equals negative 10. And then if you take a negative 10 and divide it by 0.15, you will get like 66 2/3. While that doesn't fit our pattern here, because here it is going down. And this value here is above it, so therefore it can't be true. So there is no long run value for this one. All right. Here we bought a car for $26,000. Interest rate is 2.5% annually, and we are going to pay $3,000 per year. How much would you owe after each of the first 5 years? So you start out at 26,000, and then u sub n equals u sub n minus 1 times 1 plus 0.025. Since it is annually, we don't have to divide the 0.025 by anything, and then we're going to pay off $3,000. Now, if this said it was compounded, let's say quarterly, remember then you would divide this by 4. But we're not doing that in this case, so we don't have to worry about it. All right. So then you take your calculator and put that all in. 26,000 times 1 plus 0.025 minus 3,000, and you will get 23,650. That's how much you have left to pay after the first year. Then you do it again and you will get 23,000, no, we just had that, 21,241.25. Then the following year, you're going to be at 18,772.28 left to pay. The year after that, it is going to be 16,241.59 left to pay. The year after that, it is going to be 13,647.63. Then you're down to 10,988 and some change, and then 82.63. Oh, let's write that better. And then you're going to be at 54.70, and then at 2606.88. And this is the value where you can stop at, because this number here is less than our $3,000 payment. So, how many times did we have to pay $3,000? Well, we paid $3,000 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 times we paid $3,000, and then we still have $2,000 left to pay. So how many years to pay this off? It is going to take us 10 years to pay it off. Then how much did you spend in all? Well, we spent $3,000 9 times. And then we also have to, in the last month or last year, pay $2,606.88. So we have 9 times 3,000 plus 2606.88. So our total bill comes to $29,606.88. That was the cost, actual cost of the car. Okay, so you just have to remember to count everything up until you have a number that is below your payment amount. And then the number of times to pay it off has to be one more than whatever you get for this. And then when you're figuring out the total payment, you count how many times, whatever, to get to this number and multiply it by your payment amount. And then you have to add that much into your total. And it should be more than what you borrowed to begin with. All right, then let's see here. We have an equation to solve for, let's see, we're going to solve this thing for x, I do believe. Oh no, let's solve for y. So in order to solve for y, the first thing we're going to have to do is distribute the 2 to those two things, and it's a negative 2. So 3x minus 2y minus 8 equals, and then distribute the positive 2 on this side, 2y minus 12. Now, since we're trying to solve for y, we're going to get the y's on the same side. And let's see, I'm going to move the y's to the right side. So we're going to add 2y. And we're going to add 12. So that we can just isolate the y on the right side. 2y and 2y is 4y. Negative 12 and positive 12 is 0. So then we're left with 3x plus 4. And finally then, to get y by itself, we would divide by 4. And y is equal to 3/4 x plus 1. Hey, and that's a line. Slope is 3/4. Y-intercept is 1. All right, now solving this inequality. Because the variable is in the middle here, we have to isolate the variable. So first we're going to, you can either distribute the 3 or you can divide by 3. So we're going to distribute the 3. Negative 9 less than or equal to 15 minus 3x less than 12. Then we're going to subtract 15, and we have to subtract 15 from both parts of the inequality. This part is a negative 24 is less than or equal to a negative 3x, which is less than a negative 3. Finally, you would divide by a negative 3, and you will get x, and that is 1, and that is 8. And now, because we're dividing by a negative number, we have to flip the inequality. So it becomes 8 is greater than or equal to x, which is greater than 1. If you were putting this on a number line, 8 is there, positive 1 is there, closed circle at both spots. Oh no, check that. This one does not have a closed circle. It should be an open circle. And then a segment connecting them. And the reason the 1 is an open circle is because it's just greater than, and 8 is greater than or equal to. All right, next type, I should say, is an absolute value equation. This one happens to be an inequality. So the first thing you have to do is get rid of the absolute value symbols, so it becomes 4x plus 3 less than 13 greater than a negative 13. Just move this to the other side. Keep the sign in the same direction. So now we subtract 3. And at this point then, that is a negative 16 less than 4x less than 10. And now we have to divide by 4, which leaves us with a negative 4 is less than x, which is less than 5 over 2. And so if you were to put this on a number line, at a negative 4, and at 5 over 2, which is 2.5, you would have open circles. And x is less than 5 halves, and x is greater than a negative 4, so you connect them. And here we have one last question. Here's a sequence, and we want to figure out just what is the 10th term and what's the sequence. So let's see. U sub 1 is 4. U sub n equals U sub n minus 1. And then let's see, from there to there, we have to add 8. You're going to add 8. And you're going to add 8. So plus 8. So this is the first term. That's the second. That's the third. That's the fourth. We need to go over here to the 10th. So we have to add 8, add 8, add 8, add 8. So this would be the 5, 6, 7, 8, add 8, 9, one more add 8 to the 10th term. How many more 8s did we have to add? 1, 2, 3, 4, 5, 6. And 48, because 6 times 8 equals 48, plus 28, which you started with, that is 76. Now all you have to do is just put 4 plus 8 into your calculator, and it gets 12, and then if you use ANS plus 8, that will get you the 20, and then you have to push your equal sign 8 more times, and you will get to 76 then. And the way this is written, because we called this one U1, then this one would be, let's see, U2, U1, U2, U3, U4, U5, U6, U7, U8, U9, U10. And that is what your test will be like tomorrow. Good luck.